in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
What is up, everybody? Sorry, we're having some a lot of technical issues today. That's why the stream was delayed about, what was it, 10 minutes? Yeah, my bad. Well, not my bad. Windows is bad.
Surprise, motherfucker.
Okay, let me turn on the TikTok, then I'll turn on the Discord. Give me a sec. Okay, let's go live there. Let's come over here. What up, Chantrix? What up, bro? Where are my windows? This is it. Is this one getting displayed yet? No, it's not. Okay, that's the wrong one. Ah, it's displaying this one. Oh, okay. My bad. One sec. There we go. Let's fix that. Also, I think I'm getting sick. No. Why? Not now. Okay, there we go. There we go. We got some math over there. Let me get Discord running. One sec. Pop out. There we go. Dun, dun, dun. Screens. Good, cool. We're live there. That works. What else did I wanted to change something else. I think I forget it was. It's always something. There's always something I need to like fix. No, you know what? I think it's okay. Oh, I know what I am gonna do. I'm gonna set a timer so that I know to renew the TikTok before the hour gets up and they get mad at me. They make you like fill out some captcha to make sure you're not a bot just streaming yourself sleeping, I guess. Hello, whip it out, bro. Give you $100. You can pay my lawyer fees too, as well, Jalen. There, bro. What's up, Zach? Good to see you, Sir Zachary. Shout out to Zach. I like Zach. How was my first day teaching? Oh yeah, I did do that today. That's right. Yes, today was my first day teaching physics to 180 plus pre-med students. It's the first day, so it's not like too crazy of a day. I kind of spent the first 20-30 minutes just introducing who I was, what the class was, telling them a little bit about myself, the syllabus, how things are going to work. And then I asked if they had any questions. They didn't say they had any questions. They're like, no questions. I was like, okay, cool. What's up, Box Vlog? What's up, Equity? Good to see you, dude. Yeah, I started going into units conversions, actually, is what I did. I started... This week is the first week, and a lot of kids will be just switching classes in and out, so I don't want to put anything super physicsy that's required the first week, but I'm doing a math review for the kids that are there for the first week. So that's going to include everything from vectors, units conversion, how to solve systems of equations, all sorts of fun stuff. So yeah, we're going to be doing that. Semester did just start for UCLA. Today was the first day. First day for UCLA. Yeah. And I got 10 weeks of this. And then I got a little bit of a break. And then I'm on 5 days a week for the summer. And I may live stream those because that class is all online. This is in person. Like, I had to actually go in and, put on a suit and things. And here, I can show you guys. I have a picture I took of myself. It's actually kind of funny. Instagram. Go to Instagram. Where is... Not this page. Where's me? Where is me? There I am. Yes, this is kind of a fun picture. So the picture on the top here is when I started at UCLA as a graduate student in 2012. So that's 2012 Dr. Gold. And then this down here is me teaching physics today. So I thought it was kind of fun. A little 13-year gap between being a student at UCLA and being a teacher at UCLA. Your streak got resetted? Oh no, dude. Did any of the students recognize you in class? What do you mean, recognize me from the stream here? No, I don't think so. I don't think they've discovered my stream yet. Although it's not going to be very hard for them to not do that. So I did have to make my personal Instagram private because, I don't know. I don't want someone yelling to the administration that, I don't know, he takes his shirt off or he goes to Desert Raid. Or, not that I really care, but before and after gold. That is true. Yeah, this is my pre-gilded age. This is my post-gilded age. Yeah. It's kind of cool. Anyways. Yeah, that's that for today. That's what happened today, I guess. It's Monday, start of the week. A couple students are coming back from spring break, I guess. If you're at UCLA, it's the first week of school. So, time to help. Yeah. Oh, thanks, Zach. Yeah. It's cool. It's an interesting opportunity to formally teach in a lecture hall to like a bunch of people. Nice. I'm excited to see what happens. I can already tell this is going to be a lot more work than I thought this was going to be. Because this weekend, I was already spending a couple hours trying to formulate classes and stuff I wanted to set up and like homeworks, and I'm already getting emails from students asking questions. You know, how many classes can I miss? I have a wedding, blah, blah, blah. I'm like, oh man, here we go. Yeah. What's up, Alan? Yeah, lesson planning is hard. Yeah, I'm going to try to make the lesson planning easy. So I'm basically just going to do what I do here on the stream. But instead of the students asking questions, I'm going to just do a couple questions from the chapters. So, yeah, the first week of classes here that I'm doing is I'm doing core math skills for physics. So I'm going to be doing, this first section was converting units. So today I just did some examples of like how to convert kilometers to miles. I did a fun question here where I asked the students to tell me what their favorite soda was or favorite drink. They said Diet Coke. I was like, wow, Diet Coke's making a comeback. Diet Coke was like not cool in my generation. It was, deemed as the aspartame cancer killer. But I did a question where I said, how many cans of Coke can you fit in the trunk of a car? And I asked them what car. And someone said a Prius. So I kind of chastised them. I was like, a Prius? What? You said a Prius? But anyways, we came up and did the math. It's actually a cool question. I'll do it later if we just have like time and no one's really asking things. I'll do the question because it is fun. So that was a little humorous. And then I did a simple figuring out how fast like Usain Bolt can run in miles per hour, which came out to be 25 miles per hour. The fastest man on earth can run at 25 miles per hour, which is still within the speed limit. for California, you know, Highway Patrol. Anyways, yeah, and later in the week, I'll probably do order of operations, PEMDAS, exponents, radicals. A lot of this stuff comes back actually from, we did a summer camp in 2022 for students to just kind of catch up on some remedial math skills. And so these are really helpful things, product rules, quotient rules. And then I'm going to finish the week with teaching some tricks for systems of equations and vectors. I'm going to try to teach vectors. I think vectors is where they're going to start, like, crying. They're going to get upset when I start going through vectors. Anyways, gold suit is nice, thanks, yeah. The semester ends at UCLA on June 9th, or the quarter, I should say. And then the summer session, I believe, starts the 20th. So I get, like, an 11-day break, and then it's just, like, hitting it again. This looks like high school stuff. Honestly, it is. A lot of the math here is high school stuff, but it's to make sure that students remember math, because you need math to do physics. If you don't know math, you're not going to have a good time in physics. No. So I want to make sure everyone remembers base level math. This is first year university. This is also physics for life science majors. So what that means is this is for people who are not technically super inclined to do physics. They're doing it as it's like a side requirement for them. It's mainly pre-meds is what it is. So it's students who want to become medical doctors and they have to take physics, because some physics is actually on the MCAT as well. And so this is equivalent to what AP Physics 1 would be in the US. So for those US people who know the AP exam, this is like AP Physics 1, whereas physics for engineers, or physics for physicists is what they say, that would be AP Physics C. So that's a calculus-based. This is an algebra-based physics class. So, yeah. If you're looking at this and you're like, oh, I could do this. This is high school stuff. Yeah, you could. It's basically high school physics being taught at college. But it's like AP Physics 1, high school. So, yeah. Yeah. I gotta be careful though. Today during lecture, I was just showing some examples of units and things, and I was work and F equals MA, and I said, oh, I assume you guys have taken at least high school physics, like what's force equal to, mass and acceleration. Some kid like emailed me 4 minutes later, saying, excuse me, sir, like I haven't taken any physics in my life, and I believe the course description says that you don't need to have any physics knowledge before this. I would appreciate if you taught this from the ground up with no expectation of physics knowledge. And I was like, okay, dude. Yes. I mean, yeah, I will. Well, first of all, don't tell me how to teach. You can ask me. Like, hey, it would be helpful. But also, I wasn't like assuming that you have to know physics before taking this class. I was just making a comment. Anyways, so I don't know. I see how this is now. I have to kind of be careful about what I say, because they're gonna hold me to the record on it. Yeah, I got a bunch of lawyers in the class. Anyways, yeah. Oh, thanks for the raid, Obi. What's up, Obi? Big shout out to Obi. Obi's a great guy. Anyways, cool. Hey yeah, Obi. What time is it over there for you? Let's see. Time UK. It is currently 11:22 in the evening. Nice. Okay. That being said, let's start off the stream and help you guys out with some math and science homework questions. Let's go. Welcome everyone, office hours. My name is Dr. Gold, Actual Education. Stream helps you out with math, homework, science homework. All sorts of fun stuff. 23:22. Oh yeah, the 24-hour time. That is correct. Yeah. For those of you joining us on YouTube, TikTok, if you want to get some help with your math and science homework questions, we're gonna do them live here on the stream. All you got to do is submit them to that website down there, which says actualdiscord.com/submit, and we'll help you out. All right. But today's looks like we got one from Adarsh, we got Reki, we got Shantrix. Nice. The homies. And then maybe I'll show you guys how to calculate how many Coke cans you can fit in a Prius. It's kind of fun, actually. Okay, cool. Let's see. Is Adarsh, you around here in the chat? Adarsh, what's up? Yo. Okay, cool. they're asking you to figure out what this angle is, I guess. Is that kind of what they're asking you? I forget if this is called the principal angle. It's definitely not the reference angle. I don't even remember what those terms are called, actually. Principal angle. How many Cokes can fit in Uranus? Dude, if I had said that. I should have done that, actually. It would have been hilarious. I think... Let me, one sec. Let me see. Principal angles, I think, are positive, right? And they're from 0 to 2 pi. I think that's what they are. Oh, thanks for the follow, Alpha. Yeah. There we go. Yeah, this is the difference. Aha. Yeah, I like that. Oh, yes, dude. Yes. We got here we got Master Chief coming out. Yeah. So here, let me explain to the difference here between principal angles and reference angles. So principal angles are always measured from this axis, or sorry, they're measured from here. They're measured from like the east, or I would say like the positive x-axis. So even if you go backwards or you go, I don't know, all the way around this way, you're always going to measure it from here. So in this case, this is 240. You could have measured this, right, going clockwise, which is the opposite for angles. That's negative angles. And this would be negative 120 degrees. That's the regular angle, but the principal angle is always a positive one, and it goes from here to here. And then that would have to be 240, because if this is 120, they need to add up to 360 to do a loop. So yeah. The reference angle is the more important thing, and that's the angle that this point makes with this axis, like right here. That's called the reference angle, and that's a very important angle for like figuring things. Oh, interesting. I like this. This is a cool little thing Shantrick showed. Yeah. I love all these fun little charts, but also I would hate to memorize this. Right? This looks like a lot of stuff you got to do. So, yeah, this is correct. So, reference angle is 180 minus the angle. Reference angle is equal to the angle. Reference angle is angle minus... See, this is the flip thing. And then this is 360 minus the angle. Oh, man. Yeah. In general, just draw your angle, and you just need to, like, connect this to here. And then you figure out what this is based on, like, what this is. I would rather you find it out the intuitive way. This is cool. I mean, this is true. But I would hate to memorize this. I wouldn't memorize this. It's something I've come to really appreciate as I, like, get older is with my limited memory, there's only so many facts you want to just commit to your brain. And it's better to just commit the process, because then you can always just do the process again. But okay. Let's see. I assume in this case, they're asking you to just figure out what's called the principal angle. Which is going all the way this way. Okay, cool. One sec. Let me make sure the audio is working on TikTok. I always hate if it's not. Right. I agree. Yeah. If you're like super pressed for time and you're not gonna be able to do it, then you should definitely memorize. But yeah, in general, we don't like to memorize. Okay, nice, sweet, cool. TikTok's working fine. That's great. Okay. I reserve my memory for crucial stuff like the mitochondria being the powerhouse of the cell. Bro, Saint Ross, dude. That's one of the biggest memes in biology, right? The fucking mitochondria. I don't know. It's one of the reasons I never really liked biology, because I felt a lot of it was just memorizing things, which I don't know. It's kind of useless. It's good to know things off the top of your head for sure, but just memorizing little facts that I can just look up later. My memory is used to store all the questions Shantrix has asked in the past. Yes, thank you, Endar. I appreciate when you can recognize that the triangle problems are the same. Anyways. Yeah, all right, so let's get to figuring out this angle. So they say what they're doing here is they're giving you a coordinate for the point, okay? And this is going to tell you the amount in x, and this is going to tell you the amount in y. Now, whenever I see things like this, I like to like draw the triangle. And are looking at your question. Yeah, that's a good one. I love that meme. So let's see. This is the point, okay? And then what we know is that in this direction, it's going to be going down 1, okay? So I can think about this as having a length of 1. And then the negative square root of 3 means it's going to the left square root of 3. So we're going to call that the square root of 3. Okay? And now what we're being asked to do is figure out what this whole angle is here. Now, I know getting from here to here is 180 degrees, okay? So all I need to do is figure out what this last part is, right? If I could figure this out, then we're Gucci, okay? How to do that? So this looks like one of those special triangles, and the ones that we learn, these are the ones that, if you are going to memorize some things in math, I would memorize these things. So this is, for instance, what's called like the, all right, let me make this a little bit more accurate. There we go. This is called the 30, 60, 90. Okay. This is 30, and this is 60. And what the sides for this triangle are is 1/2 square root of 3 over 2. Okay? The other way they learn this is they just multiply everything by 2 here. Is there a list of... you just need to know the 30, 60, 90 and the 45, 45, 90. That's the only one you really need to do. But watch what happens. If I multiply every side here by 2, you get the same triangle first off. This is called like putting something up by a scale factor. This like goes away. And you're going to get the square root of 3 over 2, 1 over here, and then this is going to become 2. Yeah. Raven's right, correct. There's only really 2 triangles you need to know. It's the 30, 60, 90, and the 45, 45, 90. If you know those 2, you can do pretty much all of the angles in trig math stuff. It's not that. Also, this is so much better than memorizing unit circle. I hate the unit circle. It's so much better to just know these 2 triangles, and then you can figure out the unit circle for anything. But okay, so now that I know that one of these sides is 1 and one of these sides is square root of 3, I know right off the bat that that looks like this triangle, right? So, cool. Now all we gotta do is just match up the sides. What about a 3, 4, 5? You don't need to memorize the angles there. They are useful. I think it's like 55 point something, 30, like 20. What is it? What's up, Ace? 3, 4, 5 triangle is useful to memorize. That's useful to memorize side lengths. But you don't need to memorize the angles and the side lengths for that one. Just the side lengths. Those are called Pythagorean triples. Been a while. Yeah. What's up, dog? Okay, so this one looks like this one, so now we just got to match up the angles. So I know the square root of 3 is opposite the 60 degree side, right? So that means opposite of this one right here is going to be 60 degrees. And that means the other one, which is opposite the 1 side, right? See how this is opposite the 1? Is the 30 degree angle. My teacher said you only find the 6, only to find the 6 trig functions. Okay. But probably for any angle that's like a 30, 60, 90, 45 multiple, right? Yeah. I was locked in, though. If you check good grades, you will see why. Oh, good. Okay. I will check. Yeah, it's the end of the month. So, yeah, I got to go check all your guys' grades. Are you doing well, Aced? I hope you are. So, right. So that tells me right away, this is 30 degrees, okay? This is 180 degrees. So adding the 2 together will get you your total angle, which is going to equal 210 degrees.
Good job.
Everything 95? Nice, dude. Love that, Ace. Good job.
Hey, come on.
Hey, Gold, how's class? Yeah, class was good. They're a little quiet. I can tell. They're nervous. It's like the first day of class. No one really knows each other. But Also, I have like no reviews on any of their like Rate My Professor websites, so they have no clue who I am. But I did manage to get them to laugh a little bit. So it was helpful. I will say, yeah, the first like minute or two, I was kind of even myself like a little stage fright, I guess. I was saying a lot. I catch myself pretty quick when I start saying that, and I think, oh no, I need to slow down and think through my words more. But after the first like 5-10 minutes, it was fine. I was back in. I mean, I do this how many days a week? How many hours? It's basically a stage. It's just I can't see you guys, but I can't really see them either because there's so many of them. It's like this big blob of like 200 students in a stadium, basically. It's very interesting. Anyways, okay, cool. Yeah, this one's 210 degrees, Adarsh. And if they wanted you to know the reference angle, that would be the 30 degrees here. So we would say reference is equal to 30 degrees. Yeah. And yeah. So now that you know that, yeah, 200 seems crazy. Yeah, it's a lot of kids. They were like, there's like a wait list for the class because there's only 2 sections for this class. And there were kids just hanging out on the stairs. They were just like sitting like on the floor. I was like, oh no. Oh no. Anyways. Okay, so now that we know this, right? And you want to get some of the trig functions, okay? We can write them out. So those trig functions are sine. We're going to say sine of theta. Cosine of theta. Tangent of theta, and then the corresponding flippy ones. So this is going to be cosecant of theta, secant of theta, and then cotangent of theta. You got a B on your Calc 2 exam? Good job, dude. Good job, DJ Oxy. Nice, dude. SR, yeah, standing room only when Dr. Gold takes the stage. Yeah. They're funny. Funny kids. Okay, cool. All right. I think I lucked out on TA because I met with my single TA that I get. Usually you get 3, but I only get 1, apparently, because budget cuts or something. But she seems like a super cool, chill person who actually gives a shit about teaching. Nice. And has a similar mentality that I do, that we don't need to be like knocking points off for like getting decimals wrong. What's up, Syntax? Ooh, I like that, Shantrix. There's a video about familiar rehearse stuff when they say less ums. Yeah, if I had I don't want to really like rehearse my lectures per se, but if I did, you're right. I would probably say a lot less ums. Yeah, doing well, good, nice. Okay, so yeah, now that you have your triangle here, Adarsh, and also I'm gonna put the negatives on things now because this is down, so this is -1. And this is to the left, so this is negative square root of 3. And then that means the hypotenuse, this missing side, would be 2. This is always positive. This is never negative. You can never have the hypotenuse being negative. It's always positive. Okay. So once we have these, here, we've written a lot of stuff. Let me like put this somewhere else. So it doesn't look so terrible. Just trying to clear some space for you. Okay. What I like to do is then write out what all the different things are. So this is -1. No, sorry, negative square root of 3. Oh, you passed your theoretical physics exam? Nice job, Zorn. I enjoyed your questions. They were difficult, but they were fun. All the transferring between coordinates and stuff. Congrats on passing, dude. Love to hear that. Love it. Don't be discouraged. Your physics classes are hard. Like, don't think you're dumb. You're not dumb. Your classes are hard. Could I ask a question about set theory thing after you're done with this, or you choose what? There is a queue, but if you just want to ask something quick in the chat, I can definitely try to help. I don't know that much about set theory. I'll be honest, but there are some people watching my stream right now who are really good at that type of stuff. I can think of some people like e to the 2i pi is good, or pen center, or Eric, any sorts. If you ask your question in the chat, and I'm sure it's one of the other math fun people here will be able to answer it. I'll take a stab at it as well. So tangent is positive. Yeah. So here's what so first I messed this up, dude. What? I messed up. It's not negative square root. Can't have two negative square root of 3s. This is just -1. Okay. And then this is not 1. This is 2. There we go. Okay. What do you do in life, sir, if you don't mind me asking? Are you an engineer? I am a teacher. I teach. I run a nonprofit, and I do know how to solve electrostatics. Yeah. If you want to submit a question on electrostatics, use the link down below. I will do it during this stream. I like electrostatics. I'm a big fan of those. Okay. So, this is going to be, this side right here is what we're going to call the adjacent. This side right here in green is going to be called the opposite. Oh, elastostatics. Oh. I mean, you can try me. I'll try to solve it. I maybe it's a different word that I'm used to it being. And this is the hypotenuse. So, right, SOHCAHTOA. This is sine is opposite. Here, right, SOHCAHTOA. Sine is opposite over hypotenuse. So sine would be -1/2. So it's -1/2. Cosine is adjacent over hypotenuse. So that's going to be -3/2. So that's -3/2. And then tangent, which is opposite over adjacent, that's going to be equal to 1/3, which your teacher may get mad writing this way, and they would prefer you to do it as √3/3. That comes from just multiplying the top and bottom by √3. And you're right, it is positive in this quadrant because you have a negative and a negative. Can we use theta as the reference angle? No. The reference angle in this case is going to be 30. That's the reference angle. But in order to get these results, you need to put the full 210 in for the calc. If you want these results from the calculator, you need to put the full 210. So here, this is the reference angle. And then this angle right here, 210. That's equal to the, that's the principal angle, I think is what we call it. Okay, and then doing these are just the flips. So this is just going to be 2/1, which is equals to 2. This is going to be 2 over the square root of 3, which is 2 square root of 3/3. And then this is just going to be equal to the square root of 3. What's up, Fred? Appreciate your message that you sent. Yeah, we're going to meet on Thursday or Friday, right? That's what we said on DMs. Yes. Amsterdam. I didn't realize you're in Amsterdam. That's such a fun place. We actually have one of my students is actually in Amsterdam this weekend. He keeps sending me like pictures of joints. He just keeps going to all the tea houses. Nice. Thanks for the follow, Rush. Let me see. What was the question that someone asked about set theory here? Am I off by a negative on secant? I am. I am. This should be a negative here. Wow, double follows. Thank you, bros. Let me see. What was syntax said? Am I allowed to prove set theory identities by making a truth table? Oh, with logic. I love truth tables actually. That's a good question. I guess if you can prove it for everything in your set with a truth table, then you're okay. But from what I understand, a lot of set theory stuff involves almost like an infinite number of cases, right? You have to think about things more abstractly. In probability, or in logic, right? There's usually what we say are like binomial things. It's either like true or false, and it's usually like yes, no, very limited things. Set theory is like consider all numbers in the whatever space of this and this and this, and I think it then becomes difficult to start drawing out a truth table because you have so many cases to deal with. Oh, yeah, I messed this one up. Sorry. This is a negative here. We cannot change the negative sign, right then? Yeah, no. So if you're trying to figure out the trig identities, this has to be -1. This has to be negative square root of 3. Because it's down and to the left. Cosecant is also negative. Oh, I messed it up too. Sorry. I'm getting distracted. Thanks for the catches. Jeff's like, where are my saves, dog? Where are my saves? Let me give you your saves. Saves at Jeff. There you go. Good job, Jeff. Okay. All students take calculus. Yeah. That's another thing you could memorize, right? You could in this whole thing. You can also do like all students take calculus, and that tells you which of the trig functions are positive. So this is all, this is sine, this is tangent, and then this is cosine. That's another way to remember it. Yeah. Dude, bro, you have that on, I think you have that on your Instagram, or maybe it's your YouTube thing, Fred. I really appreciated that. I think it's one of your quotes. I stalked your socials for a bit, and you said something about like the science of like where's the minus sign. That is such theoretical physics. I have a funny story of when I was a first-year grad student. I was an experimentalist, so I'm more of, you know, screwdrivers and oscilloscopes and soldering irons. I like to do that type of stuff. And we had a theoretical graduate student like interning for the day or something, and he didn't really know what to do, and no one really had a job to give him because he didn't have like mechanical skills. So our postdoc told him to go like sweep the floors. He was like, yo, fuck this. Anyways, it was kind of a funny thing because the difference I heard the same professor talk about between an experimentalist and a theorist is, do you enjoy trying to figure out what wire is loose, or do you enjoy trying to find where you forgot the minus sign? So it's like missing wire or missing minus sign. Which one do you want to do? I prefer the missing wires, so that's why I became an experimentalist. But if you like missing minus signs, theoretical for sure. Wait, sir, what is this? I just joined. This is a stream where we help you out with math and science homework. Just submit a screenshot and we'll go over it on the stream. That's what it is. Shout out to the experimental physicists. Yeah. Were you an experimental physicist, Fred? You know what would actually be fun, Fred? Once we get to like know each other a little bit, or if you feel comfortable, I have a podcast series on Fridays that I usually have guests on, and they just like talk about life, and we have a bunch of the students ask questions about that person's trajectory and stuff. And I think it would be cool to have another physicist on. I had a quantum gravity physicist on a couple months ago. And yeah, oh, you're fully theoretical. Yeah, dope. All right, cool. That would be super cool. Yeah, I'm always up for it. Okay, nice. There we go. See? We can get our podcast guest. Cool. I'll send you out when we talk later in the week. I'll talk about it, and I'll send you the info for signing up, because that'd be super cool. Physicists try to tell us that the natural sum to -1/12. We have had some dope mathematicians too. Yeah, Zach was one of my first mathematician. I think Penn Center was the absolute first, but you were the second one. Stuff on paper is easier because I'm a typical klutz. Yeah, I appreciate like paper, pen and paper. You know what's very interesting to see is that a lot of the students these days have really bad handwriting because they don't write things by hand anymore. I doubt any of them know cursive. I mean, I barely remember cursive. I think I was one of the last cusps of the generations that learned cursive. Yeah, you don't care about minuses. Yeah. So the interesting thing in physics is a lot of times we tend to not worry about minuses until the end. And then we look at our answer and we say, does this make sense? And if it doesn't, you just slap a minus sign somewhere. You're just like, well, this should be going down, so minus, you know. I'm a hardware guy, but I was planning on being a theoretician. Interesting, Obi. Obi's another guest we had. I forgot. Yeah, I've had a couple math guys on. Yeah, Obi was one of our guests as well. Yeah. And everyone has like super interesting backgrounds. That's why I love that whole series. I just need to get better at getting guests. Okay, let's see. This is Recky's question. If only everything was as easy as slapping a minus sign on it. Yeah, what if you're going to try and buy a car and, it's 24,000? Negative 24,000. Now you pay me. Wouldn't that be nice? Just go to the dealership, slap a minus sign on the stickers. Like, it's my car now. Yeah, is this a factoring question, Reki? Where's Reki? But yes, if you found us through, I know we got quite a few people on YouTube and TikTok. There's a link down below. If you want to submit a screenshot of a homework question, we'll go over it on the stream here. Just come on by. All right, Reki, let's do this. Are they asking to factor this? Is that what this is? Okay, cool. Yes, they are asking the factor. Okay, this is an interesting case. When you have 4 terms, okay, you want to try to be able to turn it into something which is like this, like two sets of what we call binomials. Okay, this I think is technically called a quadrinomial. Someone yell at me if this is wrong. So quadrinomial means 4, nom means terms. Oh, it's a tetranomial. Ah, see, dude, this is where I mess up. Yeah, you're right. Yeah, the Greek prefixes are interesting, right? Yeah, this is tetra. They do this in chemistry too, right? Like tetrachloride. It's not quad, it's tetra. I'm trying to think what's the other one that's weird like that. What is 5? It's 5. I want to say cinco. Oh, interesting, Fred. Tetra versus quad is Latin versus Greek. Interesting. That's why I get it wrong. Yeah, the thing that always messes me up is quintic. That's it. But a 5-sided thing is penta, right? So isn't there like quint and pent? Yeah. Yeah, quintic. Quinitic. Wait. Oh, this is interesting. Wait. Shantrix has provided some information here. A polynomial with 4 terms is sometimes called a quadrinomial. This is probably AI though. So I bet the math. I trust Zach more than whatever Google AI is saying. Didn't the Romans wipe out the Greeks? Yes. That's fascinating. Okay. Well, whatever. It's 4 terms. So because there's 4 terms, and it's not AI. Oh, that's just straight up. Okay. We want to break it up into what we call our binomials. At least we can agree on bi being 2. Okay. you can just go vibes, just based on the vibes. Yeah, okay. The vibes right now are quadric. We got quadric vibes. Although I like tetra. Tetra's cool. It's a cool name. Okay. Whenever this happens, what I like to do is I want to try to group these things such that I'm gonna get the same ending result when I factor some shit out of it. Okay. So looking at this, okay, I want to try to group this in like 2 and 2. Let's see. If I tried to do this, I can show you why this won't work, first off. So if we do this, the only thing I can factor out of these 2 things is a 2. So that becomes 2xy plus 3. And then we have like minus... And then this would be x plus 24y. That's not good. Because these are not going to be the same. We don't like this. Street maths. Yeah. So what I'm going to do is I'm going to rearrange these. I'm going to rearrange this so that I have this one and this one together. And then this one and this one together. And I'll show you why. So if we have 4xy minus x. And then we're going to put this over here. And then we're going to say... plus 6 minus 24y. Now I can try to factor some stuff out. Let's do it. Here, both of these things have an x in it, so let's pull an x out. And what that leaves us left with is 4y minus 1. And then good. Yep, Shantrix. Yep. Next thing we're going to do on this one is I'm going to factor out a 6. So this is going to be plus... This is actually a cool question. I like this one because we're going to do another trick here that you need to know. And then this is going to be 1 minus 4y. Aha. They're close, right? This is almost the same thing as this. This is another big math trick that we learn. Is anytime you have a minus b, you can turn that into b minus a if you pull out a -1. If you pull out a minus sign. So if you ever see factors and binomials and stuff and you want one of them to switch, you can. Just put a -1 outside of it. Is how we do that. Yeah. It is beautiful. I do love... There he goes with the minus sign. Am I messing up the minus sign again? Don't tell me. The minus signs are interesting here. Yeah. So watch what happens. So what I'm going to do is I'm going to flip this one around. Flipsy flipsy. Where is it? Where's my flipsy flipsy noise? That's what I want. Okay. I'm going to call this -6. And then this is going to be 4y minus 1. And then we have x. And then we still have this thing. Yeah. I thought I dropped it. It's like that meme with the crown. Like, you dropped this king. You dropped this minus sign. All right. Now that these two things are the same, we love that. I can pull that out as a single thing. And I can say, okay, cool. This is 4y minus 1. And then these things are going to like come together. And it's going to be x minus 6. And the reason this happens is because if I have, for instance, a times b minus a times c, that's the same thing as b times a minus c times a. And I can factor out an a from both of these things, right? And so that's going to be, oh, cool, a, and then what would be left would be the b minus a. And then you could just move this over to this side, which is kind of what we did. So, yeah. Yeah. Dude, numbers that commute. Yes, these are nice Hermitian numbers, right? Oh, did I do it wrong? My bad. B minus C. My bad. Thank you. Yes. Sorry. This one comes here. Yeah. That's what I meant. Yeah. You're right. B minus C. B minus C. Yeah. I messed up. My brain's still a little frazzled from teaching today. Maths major. I'm a physics major. Again, we see something wrong, we just like, whatever, just fix it later. We'll fix it in post. I'll fix it in post. Anyways, yeah, that's where that comes from. Cool. Okay. Good job, Reki.
Well done! Well done!
All right, let's see. Next question up. He says it's an algebra question. I'm glad that this is only question 22 from whatever Cayley or Fermat thing this is. Gabriel says, how highly do you recommend using AI for high school physics concepts and questions? At this point, a lot, because it's pretty damn good, I would say. Now, I would use it as a tool. Don't use it to do your homework. But you can use it as a way to check what you're doing is correct. I do that all the time. I'll do a problem. I'll think I have an answer. Then I'll ask AI. If AI gets the same answer, then I know I'm right. If it gets a different answer, AI could be wrong. But it at least allows me to critically look at each step I took and each step it took. And then I get to compare. So, I wouldn't rely on it 100%, Gabriel. But you can definitely use it as a tool. Exactly, Fred. It's incredibly powerful. Yeah, I will AI is great for giving the inspiration sometimes, especially in difficult questions like this one I'm sure Shantrix gave me, where there's like a trick you need to know. AI can sometimes pick out the trick for me, and then once I know the trick, I can run it. Yeah, use it for learning or for tedious work and stuff. Yeah. Okay, in the diagram, PQRS has a side length of 42. Okay, so the whole thing's 42. That's nice. Answer to life, the universe, and everything. Okay, so this side is 42. Cool. And it's divided into 4. The last time I gave an integral to AI, it argued with me that it was right. Yeah, with integration, it may not be as good. With just general physics, it tends to be okay. Chemistry, it is boss mode at. Chemistry, AI is very good with chem. For whatever reason, I think chemistry people just post more of their content online, but the model is trained really well on chem. Yeah. Also, prompt trick for using it. If you're not sure if something is true, ask the AI to show it's not true. Oh, I like that. Yeah. Oh, that's a cool trick. Yeah, that's some prompt engineering. Chemistry requires less intelligence. I mean, it's not as math heavy, I guess. Okay. If each of these 4 rectangles has the same perimeter, what is the area of the shaded triangle? Oh, geez. Okay. Ooh. Okay, I'm going to assign some variables to things. So I'm going to call this side just default. This is my brain running on autopilot. I'm going to call this X. I'm going to call this Y. I'm going to call this Z. I see. Actually, yeah. And then because of that, I know this side is 42, so this must be 42 minus Z. And then because this is Y, and this whole thing is 42, this side must be 42 minus Y minus X. Yeah. It's 42 minus Y minus X, I think, is what this one is, right? And then I want this and this. Maybe I should have written it. Nah, you know what? No, whatever. We're just going to leave it. Or let's see. Okay. So, in order to find... So, we have 3 variables I don't know. X, Y, and Z. So, I need to come up with 3 equations, at least. And the nice thing is, I know all the perimeters have to be the same. So, each perimeter is an equation. So, that's 4 perimeters. That's 4 equations. Although I know they're all equal to each other, I guess. If each of these 4... Okay. So, there's actually some unknown variable, let's just say A, or let's just say P, which is equal to the perimeter. So actually, you do need all 4 equations. I'll show you why. Okay, so for this rectangle, I have 2x plus 42 must be equal to P. Plus, sorry, 94. 84. Yeah. Because it's 42 and 42. So x, 2x, 42, 42, 84. I do A-level physics here in the UK, and it's rough. You should do an exam paper for cool content. I have done A-level questions. If you have an example one that you want me to go through, you can just take a screenshot of one of your A-level questions, throw it in the website, and we'll go through it. 84 plus 2x. Oh, wow. I like that. Yeah, he already Zach already sees a shortcut. Okay. 84 plus 2z. Ooh, where are we getting the 84 plus 2z though? No, because this is not 84. This is not 84. This is 42 minus x. Yeah. Okay. This is number 1. You're good, Zach. Number 2. Now we have this side and this side, so that's 84 minus 2z plus 2y, and that's also equal to p. And then we have, yeah, all good, Zach. Yeah, it's hard to see this. I would also think it's like 42, but no, it's 42 minus x. Yeah, because this right here is 42 minus x for this amount. So now we have 42 minus, so, okay, question 3. So I got 84 minus 2x plus 2z is equal to p. And then we got one left, which is here. Call this number 1. So this is a monster of 1. This is 84 minus 2y minus 2x plus 84 minus 2z, and that's also equal to p. What's up, Zigzag? Right side of the shaded is also y. Left side is 2y. I don't think we know that per se, though, do we? I don't think we know that this and this are the same size. Maybe you're right, though. We'll check it. Okay. The top right triangles share that length. The top right rectangles share. Oh, they share this length for sure. Right, they do share the 42, the 84 minus 2z, which was. Did we write that one? Yeah, that was here. Yeah, you're saying that this and this are shared. Yeah. Oh, I see. This is actually pretty cool. Yeah, there's a lot of different ways we could do this. Those do have to be the same size. They have the same perimeter. They have to have equal perimeter. Oh, you're so right. I see what he's saying. He's saying that because this side and this side of this rectangle is the same as this side and this side, and they have to have the same perimeter, that tells me automatically that this side and this side are the same. You're so right. Thank you, Endar. That's a cool realization. And I think that will pop out actually here. So if, for instance, I recognize, right, that this thing comes up twice. Okay. So what I could say is I could say that, 84 minus 2z, this thing is equal to p minus 2y. Right? And if we do that, because what triangles? Yeah, the red and the green. Yeah. Okay. Watch what happens. So then I have all of this stuff. Plus p minus 2y equals to p. This will go away. And then what do I want to show that y. Oh, we didn't write it. Oh. Well, we're going to show that y and 42 minus y minus x are the same. Okay. Which, yeah, they do. Because watch what happens. Now I have 84 minus 2x is equal to 4y. Yeah, it's a shame I didn't. It's a shame I didn't label this side the same as this one. But okay. I was hoping it would pop out, but it doesn't. Okay. Anyways, all right. So 84 minus 4y minus 2x is equal to 0 then. Okay, cool. Do we have something else with x and y in it? Oh, well, we have this thing. 2x plus 84. Oh, but I see. Let me think. Just shoving variables in would be my way of doing it, just like you did. Yeah, that's what I'm doing. But I think there's a more elegant way to do it. And I think it comes down to what Endar said when he said this is equal to this. The problem is that I labeled this not as a variable. I labeled it as 42 minus y minus x. But, okay, wait, we know that's the same, though. Okay, well, all right. So we know that 42 minus y minus x is equal to y. So now when I add y, that tells me that 42 minus x is equal to 2y, right? Or that, okay, 42 minus x is equal to 2y. So now we can plug this down into here. Let's do it. Yeah. The other way to like do this like brute force would be to just set up a matrix and solve. So what we would do is we would rearrange this to just like x, y, z, and then number, and then p, I guess is what it, no, p, and then number. I wrote the same equation just divided by 2. Oh, you're right, I did. Oh, that's where this comes from, actually. You're so right. Yeah, if I divide this by 2, we actually get this. Oh, okay, cool. Great. Yes, so we don't need to do that, because that's not going to introduce any new information. Thank you. Thank you for showing that, Fembox. Uh-oh, equations are not independent. Yeah, you're so right. Yeah, okay. Okay. And this is actually cool. This is a graphical way to show, like, when equations are not independent. If I have a fact about 2 of these rectangles, right, the red one and the green one, that I kind of got from geometry just looking at it, I'm going to get the same thing from doing the algebra of the equations. So I don't want to try to combine those 2 things. What I want to do is try to use the expression from another separate rectangle, and that should be independent, right? Side length is 42. Yes, the perimeter is not 42. Okay. All right. So, ooh, that's my 1 sec. We gotta tell TikTok that we're still humans. Give me 1 second. That's my timer. They're gonna give me like some puzzle. They give me like a puzzle. What's the puzzle today? Yep. Here we go. What it is? Which of the, dude? What, bro? I wish I could show you guys this question, dude. What the hell is this? Which of these objects has a brim? 1 sec. I'm gonna take a picture of this. TikTok be giving me some weird questions, dude. I'll show that to you guys in a second. All right, 1 second. Let me refresh because that doesn't make any sense to me. Which of these objects bounces in the corner? Yo, the captures are wild, dude. These are some wild captures. Okay, but I figured out which one it is. I'm gonna click on it. Verification complete. Okay, good. We're good for another hour. I don't know why they have this. I think probably because people just set their live streams up and just farm for like hours not doing anything. So, another 58-minute timer. Oh, yeah. You guys want to see what it was? 1 sec. Here, I'll post it in the Discord, actually. Where you guys can see it. Where's StreamerBot? Okay, cool. Yep. All right, we're gonna get started on that one. Just 1 sec. Let me see if this goes through. Go through. Come on. Yeah, there we go. So yeah, this was the question. They said, which of these objects bounces on quartz? It's like a guitar, a mug, but it's like some psychedelic like whatever thing that's going on. And then this was the other question they gave me. Which of these objects has a brim? And I saw this like SUV and I was like, oh damn, dude, what is this, like a Bimmer thing or something? But I guess it was this. It was the hat. I didn't see that. I didn't see it was the hat. It's so funny. Andrew Yang t-shirt. Oh yeah, this one. Yeah. I designed this shirt actually. It's a fun little. It was the Yang gang back when Yang was a viable presidential candidate. I campaigned for him and stuff. And I made some merch. Dr. Gold, where's my bond coin? Did I not give it to you? My bad. Wait, what? Don't say JK to me if I didn't do it. I'm pretty sure I did it. Oh, his book? Yeah, his book is great. Oh, you're right. You're right, Adarsh. I didn't give it to you. My bad. All right. Let's see. I like the puzzle design. The colors are very nice. Yeah. W calculator. Oh, you're good. You're fine. You're fine. All right. Let's keep doing this. All right. So we did the red and the green. Let's now do the blue and the. Do I want to do those? Yeah, let's do it. Let's do the blue and the orange. I think that should get us somewhere. Because I see a 2x and an 84, at least, right? So, okay. So let's combine these two. And let's just see what happens. So, that gives me that 2x plus 84 is equal to 84 minus 2x plus 2z. Okay. 84's cancel. And then we get that 4x is equal to 2z. That's nice. So that tells me right away. Oh, aqua and golden. Thank you, walking stick. Yeah, definitely not. Yeah, yeah. Why would I say orange? I messed up there, dude. That's wrong. It's gold. Okay. Yes. So this gives me z is equal to 2x. Cool. I like that. Z equals to 2x. That's a great thing. Because, well, I don't know yet. All right. All right. Now let's try to do something between. We've done the green and the red. We've done the aqua and the golden. Do we need to now combine this with this? I wonder. This is the kind of just start guessing the substitutions. Any tips for integration? Remember all the rules. Look for patterns. Certain things have patterns, like if you're going to use u sub. Like if you ever see something and you see the derivative of it also in the integral, that's a u sub question. And then if you see something that like powers need to go down, that's like integration by parts. That's what I would say. Yeah, just recognizing the patterns. So integration has a lot of tricks to it, and it's about figuring out what trick you need to use. And the best way to know what trick to use is to be familiar with what forms use what tricks. And the only way to get that is practice. Okay, 84's cancel. And now I have some beautifully ugly thing, which is that let's keep things in. Yeah, I don't know if I want to keep things in terms of z's or x, but okay. That gives me 4z is equal to 2x plus 2y. So that's another conclusion we get. Okay. I'm starting to see it maybe. Because this would get me z in terms of x and y. And this is z in terms of x and y. Okay, bingo, bingo, bingo. We can do some magic here. This is interesting. It's like a four-way systems of equations. And then what I'm doing is I'm combining them to get another set of equations, and then we're using the ones that are different there to get a final set. So I can now use this one with this one. So now you have 3. Yeah. Well, technically, there's another combination I could get. Well, actually, what is this? This is 4 choose 2. It's technically what it is. But okay, so from this one, I can say that 4z is equal to 2y plus 2x. Oh, that's the same thing. No, wait. No. 4z equals 2y plus x. Okay, and here we have 4z is equal to 2x plus 2y. Aha. Watch what happens. Unless I like messed up somewhere, and then this is gonna be tragic. Because what I'm gonna do here is now I'm just gonna subtract these two. This goes away. This is 0. This goes away. This is 0. Well, that's bad, because then that's gonna get me that x is equal to 0. I read my 42 as 4z. I did. Damn it. I know I messed up. Thank you. Thank you. You know, that's bad on my part because...
That is one big pile of shit.
Yeah. I should know that. My Z's always have lines through them. Thank you. Ruby, gold, and amethyst. All right, we'll go with that. Okay. Okay, let's get another set of equations. This will happen. Let's do gold and red. 2x plus 84 is equal to 84 minus 2y minus 2x plus 84 minus 2z. Okay, so one of the 84s goes away. This is 4x is equal to negative 2y plus 84 minus 2z. Or the other way to write this is cobalt, because there's a blue. You're right, this is cobalt. Okay, that's x in terms of y. And z, this is x in terms of y and z. Let's divide everything by 2. 2x is equal to negative y plus 42 minus z. Can I use this and this? Are they different enough? I think so. Yeah, okay. So, from this, I have 42 is equal to x plus 2y. And then from this, I have 42 is equal to 2x plus y plus z. Okay, almost there. The left two most boxed? Yeah. I'm going to use this one, right? So I can put that into here. I can say 2x is the same thing as z, right? So this is the same thing as z. So then 42 is equal to 2z plus y. Okay. Okay, I think I see where this is going. So then 84 minus 2y is equal to 4z. From here, I'm just multiplying everything by 2, and I'm moving it over so that I have 4z. Because now this is the same as this. So this is 84 minus 2y equals 2x plus 2y. And then... Oh, fuck. Well, okay. Dude, this is such a round robin of things. It would have been... Do you get a calculator on this one? I would have just put this in the calculator, honestly. Because then this is 84 minus... No. Yeah. Ooh, interesting. That gets me the same equation there. Man. Calculators allowed, but no matrices. Z equals 2x. 4z equals 2x plus 2y. Gives you y is equal to 3x. Yes. All right, let's do that. Sorry, let me do that. So Femvox is making the observation that if we bring these two together, okay, then I get that 4z is equal to... Oh, no. No, sorry. 4z would be 4x... No, 8x. Sorry. 8x is equal to 2x plus 2y. So 6x is equal to 2y. So y is equal to 3x. Okay, cool. Oh, y is equal to 3x. Good. 42 is equal to... x plus 6x. 42 is equal to 7x. Okay, cool. So that tells me x is equal to 6. Cool. X equals to 6. Y is equal to 18. Okay, then we're almost done. I just need z. And that comes from here. So then 84 minus 36 is equal to 4z. So that's 48 equals 4z. So z equals 12. Wow. Nice. Oh my god. It's so funny. Once you get that one puzzle piece, everything just starts like breaking down, and it finally makes sense. I'm so happy with that. It's just finding like which pair of equations does it, which is honestly kind of annoying. Okay, so with that information, we now know that this is 42 minus z, which means this side's going to be 30. And then this is 42 minus x minus y, so that's 42 minus 24. So that's 18. So then 18 times... So what is the area of the shaded rectangle? That's 30 times 18. Which is the same thing as 3 times 18 times 10. This is 54 times 10. 540. Answer is E. Yes. Wow.
Good job.
Oh my god.
Well done! Well done!
Yeah, let's see what the solutions are. They probably did it faster than I did it. Okay. Interesting. I like how they got Endar's thing from the start. I shouldn't recognize this from the start. This equals this. Theirs is a lot more elegant. There is a much faster way. I brute forced that for sure. They did everything just in terms of... This is actually quite crazy. They did it just in terms of x. How did they know that? Suppose that the height of the top left rectangle is 2x. 42 minus 2x. Oh, okay. Because if this is x and this... Oh, dude, that's so smart. Because this is twice this. I see. Uh-huh. How did they get that this was 4x, though? Where did they get that from? Oh. Since PQRS has side 42, then the bottom rectangle has a height of 42 minus 2x. Yeah, okay, cool. I understand that. Got you. Okay, that's cool. That's a cool way to do that. Yeah. Yeah. Nice. All right, let's see. Other questions we got. It's weird. It's weird. Not... all walks have the same distance, but the blocks are different. Yeah, the perimeters are all... yeah, that is super crazy. Okay. Cool. What's up? Next question up is going to be Equity. Equity, are you around? You in the chat, Equity? Otherwise, looks like we got a couple new people today, which I'm happy to do some new ones. Love when you guys... Gabriel, yeah, what was your question here? Oh, whoa. Oh, I know this question too. This is an A-level question for sure, Gabriel. Also your bond coin, yes. There you go. Congrats. Here, Gabriel. Yeah, let's do your question just because you're here. Yeah. I'll do yours, Gabriel. All right, let's try yours out. This looks like something with like wavelengths we're gonna deal with, yeah? Okay, here we go. E-Raven, I didn't get 10. Did I not give you your 10? Check office hours. I should have. If it was in the reward queue, I should have done it. If you just bought it today, then they process on Sundays. But I'll check it. There's a log. Okay, let's see. A loudspeaker at X produces sound waves at one frequency. The sound waves enter the tube, and the sound energy is divided equally before traveling along the fixed and movable tubes. The two waves superpose and are detected at microphone Y. Okay, very cool. The movable tube is adjusted such that D1 equals D2, and the waves travel the same distance. As the movable tube is pulled slowly out, okay, it gets quieter and then louder. That's cool. Explain the loudness of the tube, the loudness of the sound at Y as it moves. Okay, this is cool. So, yeah, this has to do with wavelength, right? So, yeah, let's consider this. I'm gonna call this path here that it takes to the left. I'm gonna call this like the red line, okay? And then I'm gonna call this path the blue line. It is interference, exactly, Femvox. Yeah, but let's explain why it is. Okay. So, in this situation, D1 equals D2, right? So, the distance that these two things travel is going to be the same. I want to get a picture actually, because I don't want to draw sine waves. Sine wave cycles PNG. Can I just get a picture of that, please? Yeah, I want a couple of them though. What, like many? This is a PNG. Oh, I like this. Here we go. Injectivity proofs. Ooh, you could try submitting one. I'll admit I don't know if I've seen that word really used very much, but yeah, you could try. Ooh, this is big. Is she a big girl? All right, here we go. Okay. Okay, so let's put a couple of these just so we can see what's happening. And then let me move this. I'm going to actually move these. Okay, and let's go up. No, that's clear. Copy. Paste. Nice. Okay. So let's say that D1 is equal to D2, Gabriel. Then that means that the distance that these things travel are the same, okay? So let's say, for instance, that they both travel... let me make this a lot thicker. They travel this far, okay? And then, right, this is the same point because it's the start. And then this is the finish, yeah? Okay. So what happened... Sorry, finish is over here. Sorry. Finish. So... if these waves travel the same distance, then when they meet up at the finishing point here, which I guess is point Y, right? Then they're going to be in phase with one another, okay? When waves are in phase with each other, it means that they're going to compound on each other and you're going to get a loud sound, okay? What's up? Hi, what's up, Solomon? Now, for instance, exactly, constructive interference. Okay. But in this case, we now start moving D2 out, okay? Such that it has to travel a longer distance, okay? So now, you could think about the end point for the blue path being over here. And so when these waves meet up at the finishing point, this would now be a negative while this would be a positive. And if you were to superimpose, so put these waves on top of each other, you would get destructive interference. So the peak from this would kill out the trough from this, and you would get 0. Exactly, yeah. That's the main concept behind here. The variation in the loudness is due to the path lengths changing. And so you could say that the waves going through D1 and D2 are no longer in phase with each other. And if they're no longer in phase, then they're going to decrease in sound. I think this is the loudest it'll be. Because they're perfectly in phase in this method. So I think this is the loudest. And then there is technically something here where you could get like the quietest. As to what that distance would need to be, it depends on the wavelength of your sound. Yeah. This is physics in the UK. This is an A-levels question. So a little bit more advanced. Yeah, it's a cool question. I like A-levels physics in the UK. They ask more conceptual questions that really test, do you understand the material, versus AP physics and stuff in the US is kind of more mechanical. Like, do you know how to get the right number? Oh, the next question is actually about that? What is the next question? Ooh, Utachi, I like yours too. That's a fun one. Yeah, so in order for these to be the quietest, okay, notice that every time, whatever let's refer to this as like D1 plus delta. Let's just say like delta X is equal to D2. There we go. Yeah, this is what I need. Okay, cool. Got it. Yeah. This is actually a cool question. I like this. Calculate the minimum distance moved by the tube for it to be the quietest. Yeah, very cool. All right. So first of all, with 800 hertz and the speed of sound being 340, this is usually 343. What I want to figure out is what a wavelength is. I want to figure out what the distance from here to here is for this sound, okay? And the way to get that is to remember that the velocity of a wave is equal to the wavelength times the frequency. So in this case, we're going to say 340 is equal to lambda times 800. So lambda is going to equal 340, so 34 over 80, so 17 over 40. So about half a meter. Okay. But that's not important so far. AP Physics in the US was rough. I was one of the... Oh, nice. Congrats to you, Flavored Dasani. Was it AP Physics 1 or AP Physics C? So, let's... Yeah. Do they say how much it has to be moved out? Calculate the minimum distance moved by the double tube. Okay. So, if you move this some delta dx, what you end up doing is changing the path length by 2 dx, or 2 delta x. Because you're going to add distance here and add distance here, okay? So, the path distance is equal to 2 delta x. Okay? Oh, nice. Grade 10. Oh, wow. That's young for physics. Okay. What you want, in order for there to be negative interference, is you want this path distance to move half a wavelength. Because, so, from a peak to a peak, that's equal to 1 wavelength, 1 lambda. In order to go from a peak to a trough, which is negative interference, you're going to want half a lambda, okay? So I need the path distance to be equal to 1/2 of a wavelength. And that 1/2 of a wavelength is 2 times the distance I push this thing out, okay? So I'm going to say 2 delta x is equal to 1/2 times, and then we found out lambda. Lambda was 17 over 40. Okay, so you get that delta x is equal to 17 over 160. Yeah, every odd half. Yeah. So what they would say is like 2n plus 1 times lambda. Yeah, that's how you get the Thanks for yeah. Thanks, fam. Yeah, I like the diagrams. I think diagrams are super cool. I'm a visual learner, and sounds.
That's dope.
Anyways, so yeah, I believe this is the answer. I believe it's this many meters. Do you have the answer? Do you have the? I always like to see if students have the solution set to what we're going through. It's just a good way for me to double check that what I'm doing is correct. I'm pretty sure I'm correct, but I make mistakes sometimes. I was making minus sign mistakes earlier today. Just pulled up for me? Yeah, cool. Yeah, I wonder if this is correct. I'm tempted. Okay. Cool. I'm going to wait for that to come in. But we'll give you a bond coin for going through this question. So, congrats. Nice. All right. Let me see. Speedster or Utachi? Utachi posted something recently, so I assume you're watching. Utachi. What's your username on one of our things? Sometimes you guys have different. Gabriel, at least, like, had the same name on TikTok and on Discord. Take the sound machine to UCLA someday, so if a student gets a question right, you can play That's Dope. Dude, I thought about it. Because I'm so used to, like, doing math with sound bites. And I'm sure they're used to it as well. I just wonder at what point the administration would get upset with me and say, okay, yeah, but you can't do that. I'd be like, no. Like, sir, this is a university, not a Wendy's. Nice, okay. So they said 0.10 meters, which, yeah, that's basically what we have, right? 17 over 160 is like 0.9. Yeah, just don't do an observation. Do they observe? I wonder if they do observe me. They probably do. They're always watching. Nice. Okay, good. Yeah, we got the same answer. Love that, Gabriel. Cool. I mean, it's correct. I don't know if... To me, if I were reading the solutions like this, if I were a student and I didn't know what the answer was, and I read this... This is the one thing I will say I dislike with the A-level stuff, is their solutions are trash. Like, yes, I know what the right answer is, but their explanations are garbage. Like, this doesn't tell you anything about why you're doing things. Yeah. Oh, is it really? Is that what it really is? One sec. Where's my calculator? Calculator. Oh, you went away, calculator. Come back. Where is she? I hate the decimals. Give me fractions. Exactly. Yeah, I'm a big fractions guy. Big fractions enjoyer. Yeah. Okay, cool. Nice. I gotta figure out why a calculator's not showing up. Oh, there it is. But where is it? What screen is it on? Where is it? One sec. There you are. Why are you not selected? Yeah, okay, there we go. Okay, there we go. Yeah, okay, so yeah, if I did 17 over 160, I'm pretty sure we get the same answer, right? 17 over 160. Yeah, 0.11, I guess it rounds to. Yeah. All right, nice. Okay. I like Utachi's question. That's a fun one too. Let me do the polarizers. This is a physics question. All right, Utachi, if you're watching, we're gonna do yours. An electric beam of 100 watts per meter squared, linearly polarized. Oh, sorry, alpha Utachi, alpha. Okay, cool, got you. I understand your name now. Okay. 100 watt meters per squared oscillates at plus 10 degrees from the vertical axis. The beam passes perpendicularly through two consecutive ideal linear polarizers. The transmission axis is tilted by minus 80 degrees from the vertical axis, and the second polarizer is tilted by 55 degrees from the vertical axis. Okay, cool. So the cool thing is that this light is already polarized. A lot of times what will happen is you have unpolarized light, that first goes through some sort of polarizer, and that instantly cuts, I believe it's half the energy out. There's an equation for this, and I think it's 1/2 cosine squared theta is what it is. Let's see. Yeah, it's cosine squared theta. Oh, this is so cool. Love that. That's a nice little diagram. Oh, they also have it in hyperphysics. Oh, intensity is cosine squared. Sorry. Energy is just cosine theta. Okay. Cool. Yeah, this is kind of decent. Oh, dude, what's going over here? Optically active substance. Ooh. Well, that's actually really interesting. Hey, dude, they have they have some weird diagrams here for polarizers. Sorry, what was the question asking though? Does it want the it does want the intensity. Okay. So it doesn't want the energy, it wants the intensity. Okay. So, that one is this equation. I guess it's called Malice's law. That's cool. All right. So the first one is plus 10 degrees. Good question here. Is plus clockwise or counterclockwise? In math, it's counterclockwise. But math and physics sometimes don't agree with each other. Like on conventions. It's quite rude, honestly. You know they don't do that with spherical coordinates. Spherical coordinates in math and spherical coordinates in physics are different. I don't know why. And actually here, let's make this kind of a, I don't know. Which one? No, I'll make this dashed. Make these dashed lines. It depends on how they define theta and phi, is what it is. It's a convention difference. Okay. Okay. So, we have light that's coming in at plus 10 degrees, okay? And the first one is minus 80 from the vertical axis, okay? So this has here. So minus 80 degrees is going to be like 10 degrees from here. Okay. And then... And the other one is 55 degrees from the vertical axis. So that's going to be this way. By 55 degrees. Okay. And our incident light is coming in at plus 10. Okay. Very cool. Ooh, interesting. I think the answer is 0. Because if the incident light here is coming in at 10 degrees, but the filter is at minus 80, and if minus 80 is pointing this way, right? Then the angle between the incident light... All right, one second, let me allow that fembox. You can say whatever. Yeah, exactly. Yeah, and yeah, it's so cool. It is very cool. Yeah. So, yeah, he's talking about, like, if you put a polarizer in between the two, yeah, that'll switch. This is also true with, like, you can test this with sunglasses. If you take 2 pairs of sunglasses that are polarized and you rotate them next to each other, you can get points where they're completely blacked out. But then if you put another pair of sunglasses in between those 2 pairs of sunglasses, I don't know how many pairs of sunglasses you own, but you can then eventually show that that it cancels it out. It's really cool. So the first one is coming in here at 10, but the polarizer is 80 from here. So the angle in between the incoming and the polarizer is 90 degrees, okay? But the cosine of 90 degrees is equal to 0. Right? So there is no light coming through here. So the answer from here is none. Okay, but then let's swap the system. Let's say instead that the light's coming from this direction. Oh, you had 3 of polarized mylar? Yeah. Yeah, you can show it. It's really cool. All right, here. Let me copy paste this picture back down. All right, we're going to swap them. We're going to swap them. I don't actually want to just have it come from the other direction, because then I'm probably going to get something with like the parity wrong or something. Okay. So Utachi, did that first one make sense why the answer is 0? Let me know. Okay, so now you have the incident light coming in 10 degrees with 55 degrees polarized. Okay, so the angle between these two things is now 45 degrees, which is just cool because they gave you nice numbers here. Because now incidence is equal to the initial intensity, which this is an intensity because it's watts per meter squared. So that's 1,000 cosine squared of 45 degrees. Cosine of 45 degrees is equal to square root of 2 over 2. So if you square that, you get 2 over 4, which is equal to 1/2. So this is nice. So the light coming out at this point is going to be at 500 watts per meter squared. And it has a new polarization at 55 degrees. That's the important thing. Whatever angle your polarizer was at, the light passing through it now has that new angle. So now this has an angle of 55 degrees. Okay. So now we're doing 55 to the 80. So that's going to be the cosine of... Oh, they gave you such nice numbers here, bro. This is cosine of 135. Very cool. So now you have 500 cosine squared of 135 degrees. And the cosine of 135 is equal to negative square root of 2 over 2. But you square it. So then it's just another 1/2. So now you get 250 watts per meter squared coming out of this one. Yeah. So that's cool. They gave you some nice numbers. They were always like 45 degrees, basically. Sick. Dope.
Good job.
Does that make sense there, Gabriel? It's not Gabriel, sorry. Utachi. Interesting how, yes, swapping the polarizers, like, changes it. Yeah, dope. Dope. Cool. Nice.
That's dope.
Okay, nice. Good job. That's a good question. I'll do the other part of your question after. Let me help someone else. But that was a good one. I like that one. That's a fun one. Okay, let's see. Who else we got up on deck? Speedster. Also, Equity. Equity, whenever you show up, please let me know, Equity. I'll skip ahead and do your question. Oh, Christ. Why? This hurts me. Why would you do this? Why would you do this as a teacher? I don't know. This to me triggers the internal screaming of students when they say, I'll never use this in the real world. You will never use this in the real world. This is too much. The concepts behind it you'll use, but it'll never be this bad. And I've done like quantum physics. It never gets this bad. Okay. The trick here is anytime we have powers to powers, you multiply the powers together, and this has to hit each individual thing, including the 2. People forget that sometimes. Which is the -2. Okay. So you're going to have -2 squared, x to the first, y to the 2/3. I'm going to distribute the things in just to like make things nice first. And then this is going to be 3 to the 1/3, x to the -1/3, y to the 1/3. Ooh, okay. I see some nice things maybe. Okay. This is still 4x to the 1/3, y to the -1/3. And then this is divided by x to the -1/3, y to the 1/3. Okay, cool. That's distributed in. Next thing to do... I guess I could combine... this is where people have a change in, like... it's like style points. Some people like to cancel stuff here first and then multiply through. Some people like to multiply through and then cancel. I think I'm in camp multiply and then cancel. Let's do that. So this is going to be 4 from here times 4. So that's going to be equal to 16. So I'm just taking care of the numbers first. Then let's take care of the x's. So x to the 1 times x to the 1/3 is the same thing as x to the 3/3 times x to the 1/3, which is equal to x to the 4/3. You add the exponents when you're multiplying things with the same base. So this will be x to the 4/3, and then 2/3 minus 1/3 is 1/3. So that's y to the 1/3. Nice. Okay. Let's keep going. This is going to be 3 to the 1/3. Minus 1/3 minus 1/3. That's x to the -2/3. 1/3 1/3. That's going to be y to the 2/3. Cool. Last-ish step is to see if... to do what's like the quotient rule for exponents. So if I have things dividing by each other, the powers subtract. I'm going to leave this. So this is 16 over, we're going to say the cube root of 3. And then 4/3 minus 2/3. It's 4/3 minus 2/3. 4/3 minus -2/3. That's going to be 6/3, right? So 4/3 minus 2/3 is equal to 6/3. 6/3 is 2. So this is going to be x squared. Then we have 1/3 minus 2/3. That's going to be -1/3. Nice. Okay, now we're done with that. Oh, okay. So let's see what we get. So negative exponents go onto the top, go to the bottom as positives. So this is 16x squared over the cubed root of 3. And then this is y to the 1/3. You should recognize that something to the 1/3 power is the same thing as the cubed root. And since we have 2 cube roots, I can combine this under 1 cube root. So we get 16x squared over the cubed root of 3y. If we really wanted to make this look nice, I would multiply the top and bottom by the cube root of 3y. This is just extra fancy. This would get me 16x squared cubed root of 3y all over... Oh, sorry, I gotta multiply by the cubed root of 3y cubed. No. Squared? Squared. Oh, that's kind of annoying, actually. Okay. So that's 9y squared over 3y. Yeah. Okay. That's like kind of the final answer. But again, that looks ugly. Whatever. It works out. 2/3. Ooh, where am I? Oh, Yes. Thank you, Flanker. Thank you, Dasani. Yeah. Yeah. I thought, oh, we'll just multiply by the square root. No, I gotta do it. I gotta do it twice. Thanks, Dasani. Yeah. Okay, nice. Good question there. Yo, is that Sam? Oh, Rushback. What's up, Rushback? Thank you. I'm gonna hydrate. Okay, this was... Whose question was this? Speedster. Okay, let's see. There you go, Speedster. I did the solution to your question, if you want to see it. You get a point. Stumbled on your video explaining derivatives was so eye-opening for me. Like, everything finally clicked. You have a gift. Thank you, bro. I appreciate that. Which derivatives was I explaining? Was it implicit derivatives? That's a very popular YouTube clip I have. I think it's my first one to do 100,000, actually. One sec. Paul H is right. Thank you, man. He's not wrong, ladies and gentlemen. Paul is not wrong. Yeah, let's see. Where's my studio? I just put out a video yesterday, actually. What did I put out? I put out a short somewhere. Ooh, yeah, logarithm rules. Oh, nice. Almost up to 1K so far. 100% likes? Wow. Yeah, this one's doing decently right now. Here are the 4 major rules. I have a part 2 I need to do. So this is for like condensing logarithms. There was a funny meme here I liked with negative and positive exponents. Where was it? Was it here? No. Where was it? No, where is it? Oh, 2 separate adding logs. We get the log of A plus the log of 1 over B. And since 1 over B is this... This is it. Yeah. Dude, I love this. Oh, yes. The negative exponent law. Positives stay in heaven. Negatives go to hell. I thought this was like the most hilarious, like, way to remember this, I guess. I don't know. I'm gonna keep this on here. There, if you guys are ever confused about, like, what to do with negative exponents. Anyways, yeah, no. Yeah, this video did pretty well, but I think the one he's talking about, I believe it was love math, but not great at it. The way you explained it was unlike anyone I've ever heard. How to subscribe immediately. Hell yeah, dude. Yeah, I think if I sort by views, it's probably this one. Yeah, this one does really well. Oh, we got a couple that are almost at 100K. See, here's the funny thing. I made these videos back in 2021. So, yeah, the other one's like balancing chemical equations, and then some of these are doing decently well. But just anybody who's aspiring to be a YouTuber or influencer, or even, I just do this because I want to put helpful content out there, and also I get tired repeating myself so many times. So I really just started making these so that all the students I tutor, I can just say, watch this video instead of me having to do it again and again. But it's a long game, is what I'll say. So that video got published almost 4 years ago, and it's only kind of recently now starting to blow up. So you really got to like plant the seeds and just put content out, and then eventually it'll catch. This may be different for like other niches. So, you know, if you're doing things in the video game niche, stuff probably needs to be recent. Luckily, math doesn't really change that much. So every year there's a new kid trying to learn implicit differentiation, and it's taught wrong. You done messed up, Aaron! So they watch my video, and then they understand it. So yeah. Anyways, sweet. All right, let's look at Utachi's other question we got coming up, and then maybe I'll show you how many Diet Coke cans fit in a Prius. That's what I taught today at my UCLA class. I taught how many Coke cans can you put in a Prius. When in doubt, throw in a dy dx. Dude, the math people get so mad at me because I'll just write out dy and dx, and then I'll divide one side by dx, and they'll be like, imagine you're doing that. It's this trick. If you have, for instance, I don't know, like 3x squared y is equal to like 4x squared, or let's just say 4x plus 2y. I'll rewrite this as like 6x dx times y plus 3x squared dy is equal to 4dx plus 2 dy. And then I'll group the dy terms. So then I'll put like this one over here. And so I'll get 6xy minus 4 dx is equal to 2 minus 3x squared dy. Sorry, I said dx. And then I'll just put this underneath this. And I'll put this underneath this. And it's done. But formal math people get really upset with me for doing that. They're like, you can't just move dx around like that. And you're probably right. You can't in the super... Yeah, see, look at Raven. He's like, no, dude. Excuse me. But it works. This is the key thing I say. Like, for a simple single derivative, it works.
No.
He's like... I don't know. That's my whole thing. Is not necessarily to be 100% by the law correct in math land, but to be good enough such that people who aren't really super math heavy people can understand it. And it'll get their foot in the door, because I feel like when you start throwing out big fancy math laws and rules, you discourage people and then they don't want to do it. But if you show them like, hey, it's actually not that hard, you just do this, they're like, oh, okay, cool, it's not that bad. Yeah, cheap and dirty tricks. It is a cheap and dirty trick, 100%. But it works, and it will work. For first derivatives, it will always work. You're right. When you get to second derivatives, it doesn't work. No. So that's when you actually have to learn how to do it. But it's to get them in the door so they don't fail out after the first one. Okay. Ooh, this looks like Zach. Look at this. E to the I phi. It's close to Zach. Zach's e to the 2 pi I, right? Okay, show that the equation is equal to 2 plus 1 plus cosine phi is correct. Okay. Wow, this is wicked. Is this a differential equation? What's up, Jazzbell? I'm tempted to write out cosine. So, I wonder if you can do this just in, like, the complex plane. Not really, though, right? Because this is 1 plus. Oh, you think it is 2 pi? Exactly. That's what I was going to say, Femvox. I was going to use the Euler identity, which says that cosine of phi, I believe, is e to the I phi minus e to the negative I phi all over 2? Is that what it is? I could be wrong. Oh, there's this identity. Oh, that's a cool one. I was right about this, though. Is the modulus squared? Ooh, I like that. Okay. Even better. Let's copy a couple of these things over. Just some, like, fun rules to have. You know, I like having things in my tool pocket. Yeah, okay. Couple formulas here that are useful. We can probably do this question a couple different ways. All right, yeah. So this is the difference between when you first start learning math and when you start doing more math. When you first start learning math, these bars mean absolute value. And then as you progress in your career of loving numbers, you start to realize that really what this is the magnitude, or this is the modulus. Right? Yeah. So, for instance, if I wanted to do the absolute value of, I don't know, x, this is kind of the same thing as the square root of x squared. Right? When you start doing things in in like vectors, let's say you have a vector that's like 3, 4. Then this becomes the square root of 3 squared plus 4 squared. This is a magnitude. And then you start dealing with like operators and stuff. This is like quantum mechanics. And you'll learn that, for instance, like psi star psi is the same thing as this, right? And so if you take a number and its complex conjugate, this is called complex conjugate, and you multiply them together, you get the modulus squared. So one way to write this would be that, like, okay, something squared, let's just call this thing z, is the same thing as z star z. So in this case, z was 1 plus e to the I phi. Z star is the complex conjugate. Complex conjugate means all you do is make anything that's I, you make it negative I. So this would be 1 plus e to the negative. Oh, that's our, one sec. We gotta solve a fun CAPTCHA for TikTok. We hit 2 hours. One sec. Please hold. Hold, please. Let's see what today's CAPTCHA is. Oh, they haven't requested it from me yet. I wonder if I just have to do it for the first hour? That would be convenient. Okay. Well, whatever. I'm gonna watch it. I'm gonna watch it for a second. Does it have a brim? Does it bounce? Yeah, right. Okay. So now that if we have these two things together, so I have 1 plus e to the negative I phi times 1 plus e to the positive I phi. Now you can FOIL things, right? So first, outer, inner, last, I don't know, whatever. I just multiply things. That times that is 1. This one times this one is e to the I phi. This one times this one is plus e to the negative I phi. And then this one times this one is e to the negative I phi, e to the positive I phi, which, again, from your exponent rules, right? Same base, different exponents, add the exponents. Negative I phi plus positive I phi is 0. And e to the 0 is just 1. Okay. Okay, so this just becomes 1, which is nice. Okay, cool. So now that's going to give me 2 plus e to the I phi plus e to the minus I phi. Very cool. Because then what I remember... Oh, I feel like I needed a minus somewhere, though. Fuck. Uh-oh. Wait, isn't cosine... Oh, cosine is plus. I wrote this down wrong. This is wrong. This one is plus. Thank you. Yeah, it's minus for sine. Sin is evil or something. Okay. Yeah. So from this, I know that 2 cosine of phi is equal to e to the I phi plus e to the negative I phi. Sorry, this one's negative, right? So this whole thing is now 2 cosine phi. So you get 2 plus 2 cosine phi, pull out the 2's, and you get 1 plus cosine phi. Which is what you wanted, and that's correct. Nice. That's a cool question.
Well done! Well done!
Good, good, Utachi. Yeah. Nice. Okay. Cool. Thank you. It was hard. Yeah, it's okay, man. Yeah, the main thing, I mean, I got tripped on this too until Fembox or Endar also, yeah, Endar, showed me that, yeah, this, I gotta remember, this is the funny thing, because I teach all levels of math. I teach everything from like middle school, high school, college. I have to kind of switch my brain in what the modes are. In middle school, this is absolute value. We don't even know what modulus is. In high school even, this is kind of, you know, magnitude, I guess. And then in college is where this starts to come in. And then that when Endar and Fembox talked about that, I was like, okay, cool. I remember now. Yeah. Masterful. Thanks, Paul. This semester for me, the bars is the cardinality of the set. Yeah, see, that's what I'm talking about. It's you keep using the same symbols, but they mean different things. It's like what's that word in English when you have words with multiple meanings? Not synonym. What's it called? Oh man, it's escaping me. This is where like I use ChatGPT and I say like that word two same word means different things. Homonyms. They're called homonyms. That's it. Homonyms. They always mean size. You're right. Yeah. So those bars do kind of always mean like some sort of size. Okay. Nice. All right. I will do one last question. And then I gotta wrap up the stream. Let's see. Is anybody else streaming right now? If anyone else is streaming, I'll go raid them instead. Just as a little reminder, we have an awesome collection of other math streamers on Twitch. There's all their Twitch usernames. And if you ever want to figure out when these people are streaming, you can use our calendar. Physics and Depressed is live. Oh, actually, I do like that guy. He's not depressed anymore, right? I think he figured out he was depressed because he was microdosing antidepressants. And he's like, I shouldn't do that. I do. Yeah, he's fun. Okay, maybe I'll skip this. We'll go, I think. But anyways, here's the calendar for when we're streaming. So Penn Center had some linear algebra classes earlier this morning. We're streaming here in the afternoon, so you can see we're going to stream tomorrow and Wednesday as well. And then Zach has a math education chat on Saturday mornings. Yeah, the calendar's great, right? This actually, if you're still in the chat, this is what I want to get you added to. So if you're another math or science streamer and you do things pretty regularly and you want to get added to this calendar so other people know when you're streaming, please reach out and I'll talk to Penn Center and we'll see about getting you on the calendar. So we can kind of, I don't know, it just kind of provide a central place. Don doesn't want to put his things on the calendar. I know, ask Don. There's some like internal discussion about that. Don was offered, but I don't think Don wants to put his things on the calendar. But he's welcome to. Anybody's, I think, welcome to. They just have to talk to Penn Center. Anyways. Okay, cool. Well, with that being said, let's close out the stream. Thank you everyone for coming to office hours today. I had a lot of fun working with you guys. Thanks again for hanging out, helping me out with all sorts of math and science we were learning today. Thanks for catching all my minus signs. Especially, yeah, thank you, Fred, as well for that. That was great. Oh, Fred, you raided me. Oh, damn, I didn't catch that. All right. Thanks for the raids, Fred and Obi. Appreciate you guys. Awesome. Yeah, so our next stream is going to be tomorrow. That'll be at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. Please come on by. Let's help you out. Get you up to speed with whatever else is going on in math and science land. We're going to go raid Physics and Depression. He's a cool guy. He does physics. So if you want to go learn some physics, go say hi to Physics and Depression for us. And make sure to join our Discord. Link's over there. And you can follow us on all the other things. Yeah, nice problem. Thanks, Fanbox. I appreciate it. All right. Take care. Have a wonderful rest of your Monday. Great start to the week. We will see you tomorrow. Peace.